Is QRP operation feasible on 80 meter? Yes, QRP or low power operation on 80 meters is entirely feasible, but it is widely considered one of the more demanding combinations in amateur radio. Success on this band with 5 to 10 watts comes down to managing the inherently high noise flow and maximizing your station's efficiency. Here are the core challenges. High QRN, that is atmospheric noise. 80 meter is highly susceptible to atmospheric static. In tropical climates, especially regional thunderstorms and static crashes, create a constantly high noise flow. A 5-watt voice signal can easily get buried under this static at the receiving station. D-layer absorption. During daylight hours, solar radiation ionizes the D layer of the ionosphere, which absorbs lower frequency RF like a sponge. This restricts daytime 80 meter propagation to purely local ground wave or near vertical incident sky wave, that is NVIS communications, typically under 200 to 300 kilometers. Antenna efficiency. Because a full wave for 80 meters is roughly 133 feet long, many operators are forced to use shortened, heavily loaded or compromised antennas. These designs are highly inefficient. If you pump 5 watts into a shortened antenna with 10% efficiency, you are radiating an effective radiated power ERP of only 0.5 watts. To make QRP work reliably on the lower bands, the margins for error are thin. A resonant antenna. A full-size resonant 80 meter dipole is your best asset. When running low power, you cannot afford matching losses in a tuner or efficiency losses in a loading coil. For regional NVIS contacts, a dipole suspended relatively low, 30 to 40 feet, works brilliantly. For DX, getting the feed point as high as possible is crucial to lower the angle of radiation. Mode selection. Digital, that is FT8 whisper or JS8 call. This is the most reliable way to make DX contacts with QRP on 80 meter. These weak signal modes use forward error correction and narrow bandwidths to decode signals deeply buried in the noise. CW, Morse code, the traditional QRP mode. The narrow bandwidth, often 500 Hz or less, concentrates all your transmitted power into a tight peak, making it much easier for the receiving station's ear and filters to separate your signals from the wideband QRN. SSB voice, the most difficult mode for 80 meter QRP. Spreading 5 to 10 watts across a 2.5 kHz audio bandwidth dilutes your power density significantly. It is absolutely possible, but it requires exceptional propagation conditions and a receiving station with excellent low noise antenna setup. Timing the gray line. The magic window for lower band DX is the gray line, the terminator between day and night. Operating right at your local sunrise or sunset can yield surprisingly long distance contacts. At these times, the D layer absorption is minimized, but the higher layers remain supportive of refraction.